Okay, it says for time greater than 30, L of t, the linear approximation to A at time equal 30. I would stop right there. So linear approximation to A, I need to remember what that means. So I have my calculator, which I can graph A. So I did that. This is A. Let's put that in blue. And the linear approximation to A at time equal 30. So that means I come over here to time equal 30, wherever that happens to be. And I make a linear approximation at that spot, which means I draw a line that is tangent at that spot. So something like that. So this is time equals 0. Nope, sorry, my bad. Time equals 30. And it's the amount of grass clippings at that time, because that's the graph of A there in blue. I should have written that in blue, I suppose. So anyway, they say this linear approximation to A at time equal 30 is a better model for the amount of grass clippings remaining in the bin, which means they're saying that after time equal 30, it's better. So here's time equal 30. After time equal 30, it's better to look at the red graph instead of looking at the blue graph. The red graph is a better approximation for the amount of clippings in the bin. That's what this sentence says. Okay, so that wasn't a question, but at least I understand what they're talking about. Use L. Okay, I can't use L unless I have L. So I'm going to have to find L. So I might as well stop now, stop reading, go find L. So L is the equation of this tangent line. We've done that quite a bit. That's this equation. So L of t is going to equal m. We're looking at time now. So t minus the time is 30 plus the y-coordinate here is a of 30. Well, to actually use this line, I have to have m, and I have to have a of 30. So I have a calculator. So I went and I have in my calculator the formula for a. That's here. So I can go find a of 30, save that in my calculator, I put that in A. So now I have a better equation for L over here. I have L of t equals, I need to find the slope. No problem, because I have A in my calculator right here. So I can find the derivative of A at time equal 30. That's this number. I put that in B. Negative 0.056. So that's over here. An annoying feature. 0.56. Parenthesis, t minus 30 plus a of 30, which is here, 0.783. Okay, so it said use L of t, so I wrote L of t, because to use L of t I've got to write it out. Getting L of t gets me 2 points. That's why you always want to do something as soon as you recognize that you can, rather than keep reading, because then you pick up points little by little, which is a much better strategy. So use L of t to predict the time. So I'm supposed to use this to figure out the time when there will be 0.5 pounds in the bin. Well, I'm trying to figure out when they're using L, so L is the red line. So I want to figure out when is the red line going to equal 0.5. So I took this same picture here and drew a line at 0.5. So that's what I've done here is I put in the A equation, the equation for my line tangent, which really, and then I drew a line at 0.5. So that's 0.5. A little hard to see right here. So I know the point of tangency is 30. So I windowed from 30 to 40. Got this picture. So I'm going to go find this point, which is the point where the red line is equal to 0.5. Turned out to be this number. Therefore, now they did say show work, so I show how I found L, and I just have to write on my paper that L of 35.054, 3 decimals always, is equal to 0.5. This gets me, so the answer is 0.5 days. No, sorry, the answer is 35.054 days. That's a point for finding the answer. They do expect you to show on your paper, since you're using your calculator to do it, that you figured out when L is equal to 0.5. That's another point. So this entire problem was worth 4 points. 2 points for the equation for L, 1 point for finding the correct number of days when L is equal to 0.5, 1 point for remembering to tell the grader that you were finding when L was equal to 0.5.